Get started a little bit. All right. Good morning, good afternoon, good evening from wherever you guys are calling. Thank you for joining us for the fifth and final part of our core concepts office hour series with KubeAcademy. This month we're focused on workloads and security. And once again, we're joined by the great Ryan Schneider. We also see Andrew Lee here, who has just joined the team. I will be here in the background as well. So without further ado, let's hand this off to Ryan.
Hey, thanks, Ian. Thanks, AJ. I appreciate it. And yes, this is part 5. If you're new to this, we've done 4 of these already. Basically, on KubeAcademy, we have a learning path called Kubernetes Core Concepts. And in there, it's made up of 5 courses that basically go through what we feel is the core concepts of Kubernetes that are relevant for you to know regardless of your role, whether it be an operator, a developer, a DevOps person, sysadmin, etc. And so it pretty much goes 1 for 1 of some lecture material along with a lab exercise after it. And so what we've done, you can take the course yourself, and then we did an office hours along with this, where every for each one of these parts, my goal is not to teach the course here. Instead, I'm going to be answering questions. And then I usually also demo the lab a little bit to keep things going and maybe do a different flair than you might have done when you went through the lab. So let me pause here. This is part 5. So if we go into the learning path, we see the various ones, and we're on part 5 here, made up of 2 lessons and a lab. So let me pause for a second. And I'm also joined here by Andrew. Andrew is just joined us on the team this week, has a really good amount of Kubernetes experience as well. And we'll be fielding probably some questions in the chat as we go along. So before we get started real quick here, hi, I'm in Central Florida, near Orlando area. And I see we have folks from Dallas. I was just there this summer, and yeah, wow, Dennis, it was extremely hot. Ian, aloha. I went to Hawaii to do a mileage run over Christmas 2 years ago, and it ended up being the mileage run that kept giving because the airlines kept extending the status. AJ and Andrew in San Jose, we were just talking about that the other day. I pick and choose sometimes whether to fly into SJC or SFO, depending upon what up and down area of the Bay Area I'm in. All right. So if you want to queue up questions, feel free to do it. What I'm going to do is I'm going to use this opportunity to maybe start demoing the first and do a little bit of talk about the additional workloads. And then we'll go into the lab on it, and I'll start demoing the lab. And then if you had questions about when you took the lab or when you did the lab yourself, let us know and we'll go through it. I'll go ahead and Dennis has a question that I'm going to answer live here. Is there a URL to the sessions 1 through 4? And these have been recorded and we had them up on YouTube. I think either AJ will probably here sometime in there pop some links in for you. We might even have a YouTube playlist for it, or are working on that. But yes, we do have those, and we're also going to add those to KubeAcademy themselves as supplemental material for this course and learning path.
I'll plug the other videos into the chat right now.
Wonderful. Thank you.
Thank you for the question.
All right. So with that, I'm going to go ahead and start this lab. So all the labs on KubeAcademy are cloud provided. You go into the environment, you don't have to install or do anything on your machine. Well, but while this is loading, let's talk a little bit. What do we mean by additional workloads? I can even just go in here and pause the video on some of the slides for simplicity. So at the end of the day, most of the stuff within Kubernetes it runs until completion, right? So we run until we're either we have complete the web server, the database, the API application until it crashes, or until we're told to shut down, or the node goes down, etc. Well, as you know, there are more than those types of applications in our environments. Most of your initial learning of Kubernetes, most of your use cases you read out there talk about those kinds of applications, the ones that stay running. Now, there's other stuff that can be done. And so it basically boils down to you have jobs, and jobs are run to completion, right? So start up, run, and quit and exit successfully. There are some people I know who actually ran Kubernetes clusters dedicated just to running jobs. Because if you think about it, if you want a distributed system for running jobs, and does anybody think of, I know I have my own personal example that I use for an example of running jobs. Does anybody have one they either use in their own workplace or that they've implemented or they know about when they think of jobs or run to completion tasks? Well, I think of like video transcoding, right? You upload a video and then a job gets kicked off in the background asynchronously. It goes off to a farm of machines that does the video transcoding, and then when it's done, we get a notification back. Sometimes reporting, right? You ever done like the takeaway or download or export your data from some cloud or service offerings? You say export, and then it says, okay, we'll come back and we'll tell you when your report's ready or when your export's ready, and then you get that asynchronous notification. That was a job running in the background, right? And sort of the list goes on and on. And so you can think about it, if you didn't want to write a bunch of software code and hook it up to message queues and so on and so forth, Kubernetes is a fairly cheap way to get distributed cron or distributed job processing, where you don't need all that, right? Instead, you just kubectl apply in job objects into the system, and then they'll run on all the various nodes. And so pretty cool if you think about that. But sometimes we run jobs for workloads like that, and sometimes we run them for one-off things as well. Another good examples of that would be some people run database routines to migrate, fix, or alter tables, add tables to an application. Some people have applications that when they deploy them, the software will automatically do that. And others, you need that step in between, right? And that could be handled by a job. So instead of doing it manually yourself, in between some kubectl apply commands, let the job do it for you. So you're still doing all the things with the Kubernetes concepts. With that, let's go ahead and jump over and start looking at the lab. Okay. So first thing that says, we're going to look at the first type of additional workload, which is a job. And jobs here, this is the Kubernetes docs for it, right?
I don't know if Ryan cut out here. Andrew, do you hear Ryan?
No, I don't hear him right now. He did have a internet issue earlier, so he may be going on to his phone to connect back in. So let's give him a moment.
Thank you all for your patience. Ryan will be coming in shortly. In the meantime, you'll notice that we did include some of the videos from the previous KubeAcademy Office Hours Core Concept series. You'll see part 1 and part 2 here. You can click on those and view that. We'll also have the playlist up here shortly as well. You guys can click on that as well. Hey, Ryan. Welcome back.
Hi all. Yes. I think they probably picked up the science and explained the situation. So I'm on my backup internet, which will not be as speedy, but should still allow us to accomplish the task. So back on here, we have the jobs definition. And so we're going to go ahead and just try to run one here. So let's go ahead and...
Are you able to share your screen back, Ryan?
That would help a lot, wouldn't it?
Just a little bit, I think.
Oh, is it turned on? Is it plugged in? Yes, it is. Now it is. Thank you, guys. So we have the definition of a job and Kubernetes box that's linked there about it all, but let's see what this thing does. So if I first, my favorite line to type, right, is favorite line to type is kubectl get pods. All right, so I don't have anything running. So let's go ahead and the instructions say we're going to curl that URL. Okay. Okay, so I have my job definition here. If we look at it, once again, the top part's the same as everything in Kubernetes. And then in the spec, basically this should look almost identical to a pod definition. Okay. And so it really is. There's nothing fundamentally different here about the spec part of it. So the fields part, we're still specifying one or more containers. The difference is how it behaves, the object behaves, or the controller that's going to process this. So we're running an image, the Perl image off of GitHub or off of Docker Hub. We're going to calculate the, we're going to calculate 2000 prime numbers, right? Okay. So now when we apply this thing, let's see what happens. All right, it's created. kubectl get pods. All right, it says it's running. Okay. Okay. Let's go see what we have. All right. So we're eventually going to see it exit. Now, let's see if we try. What's our error? Let's see what our error is first. We keep seeing it. This is actually a good live thing to show. So first we saw it running, all right? Then we see, notice which one was running, M2, MD2, MD2QL. Then that one errored, and then we have ZVFTM, and then that one's running. And now we're up to 3 errors. And that is because the behavior of Kubernetes, just like restarting a server that keeps failing to start, Kubernetes tries to reprocess the job as well. So let's go look and describe these things and see what the problem might be. Let's go look at the first one. All right. So what do we see? We see that it pulled the image, successfully pulled it, created the container, started the container, and then failed. All right, let's try to look at the logs for it. Can't use a value as an array reference. Guess what? Maybe we have a bad YAML file or have a mistake in it. Let's go take a look. Okay. Now, there's a good chance here that we might have also found a bug maybe in the past couple of months. Is it possible? Do I make sure there's no extra text inputted by myself when I was looking at this? Nope. However, did something change on the syntax with that? Can't use undefined value as an array reference at Perl. Well, let's go look at this. Let's try this first. Let's make sure our container is actually valid and works. Oh, it says basically pi is already there, so let's delete it. Okay, let's try again. Better. Okay, what's the error now? So it's running. It must be an issue with the syntax, right? So let's go and see. All right. Let's go. When all else fails, you go back in the archives. Yes, we can do that in the meantime, but it still shows the container is running. Completed. Okay, so the real question is, maybe something changed in a version of, let's try something like 5.8. I'd be surprised if that happened, but you never know. So let's go back to here. And is there just a 5.8? Yeah, there is. Okay, let's do that. Has to pull down the new container. Got it. It's running. Well, look at that. We found actually a live bug that we must have got bit by for two reasons. One, something changed in a version of Perl, and we were not locking that to it in our lab example. To be honest, we try to do that with a lot of things, and it is best practice. On this one, because we, at the lab design time, we never thought that Perl would change that syntax. We left it sort of as is, but it looks like we have our prime number, or pi, calculated to 2,000 digits. So, interestingly enough, something changed with that syntax. Offline, I'm going to have to go take a look at that and see what changed, and then update our lab instructions to lock it to an earlier version or use the new syntax. Or who knows, maybe that latest release of that Docker images might have a problem too. We don't know, but it's okay. Onward to the rest of the lab. Okay. So now this also helped us show some behavior though, right? Because what we saw was, notice it created a pod for every try. So I put in one job object, but when it was failing, I had multiple pods be created. The old pods stick around because the logs are associated with them, and and we can go back and I could look at the logs for each one of the failed attempts that Kubernetes did. I think we have someone has a question. If you could either put it in the chat there or ask it in the Q&A, I'll get to it and I'll continue on as well in parallel. Okay. Now, that's sort of how we do the debugging and look at the output. This, in the successful run, notice we only had one pod. Now, it's up to us to be able to clear that out. The person who created the job, it's up to them to know when it's safe to get rid of the pods and the job itself. If I try to kubectl apply the same job and notice it just says unchanged, right? Okay. If I wanted to run this a second time, so let's say I wanted to run it again, what would I need to do? Well, while you're guessing that, we'll try it, right? What if I go and I change it to 20 digits instead of 2,000? And I kubectl apply it. I get an error. Invalid spec type, invalid value. Yeah, these things are awesomely not awesome, right? It's a little bit of stuff to read through the lines. However, if we get through all this stuff, the very end tells us what we really want to know. The field is immutable. So that job definition was snapped at one time and is immutable. So if I wanted to do that, oops, not only would I have to change that to 2,000 or to 20, I'd have to give the job a different name. How about pi 20? And there we have it. Okay. Now, me as the person who created the job, it's now up to me to expunge it. If I delete the job, the associated pods are gone as well. Okay. So I hope this makes sense. If I list the jobs, right, I see the jobs listed, which was the actual object I put in to Kubernetes. I put in a job object, and then the job made the pods on my behalf. Let me pause here for any questions before we move on to the next part of the lab. I'll also check my internets here to see if the home one's any better. Okay, you don't, there are some questions here. Yes, I used a version, initialized VPI in the EM log, could do that. Okay. Cool. So now let's look at the next kind of job, which is the parallel jobs. Okay. Parallel jobs in Kubernetes is a way to say, I want to do things in parallel, and I want Kubernetes to break up the work for me as opposed to me doing it like myself, so to speak, right? So what's going to happen is Kubernetes is going to, a good example of this. Anybody here have to like update, 200 million rows in a database? And so you write your SQL or you write your script to do it, and then you realize how long it takes when you try it in the non-production setting. And so then you start to parallelize it, right? You say, oh, let me run 10 or 20 concurrent at a time of 10 million each or whatever it is, right? And then you do that. The same kind of idea here. And so what we're going to do is there's a lot here. If we look at the parallel job, we'll go ahead and download it. Okay. So we're going to calculate prime numbers in this sense. So the syntax looks almost exactly the same as we saw on the before, but now we have parallelism, right? So instead of when we use deployments and stateful sets and things like that, we have the replicas field that says how many pods should be running at one time and stay running. The parallelism is a very similar concept, but they're happening at the same time, and they're going to exit independently for the most part of one another, right? So we have the parallelism added. So what we're going to do is we're going to go ahead and do a watch over here on this object that we're going to stuff into Kubernetes. So while that's running, oops, sorry for the accidental click there. While that's running, we're going to go ahead and apply it. And we have the 3 pods done in parallel all at the same time, running independent. Completed, 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 right? And now that is a way for Kubernetes to do the parallelisms within the job concept, right? So I have, if I look at the jobs, notice I have one job object I put into Kubernetes. 3 of them ran 1 time a piece out of 3 is what that refers to. So it's saying 3 of them actually started up and 3 of them ran once out of the 3 that are supposed to be there. But notice when I do my kubectl get pods, I see the 3 individual pods, right? So we have basically the beginning part, dash, and then the hash for the individual pods that were created. The output of these jobs could be standard out, like an ID. It could be dropping a message on a queue. It could be putting the resulting data it did into an S3 bucket or something like that. You know, it depends upon the business logic and the architecture you're doing. Now, a lot of times what you do with these, with the parallelized work in Kubernetes, is you have them pull from message queues, right? So basically, the linked here example talks about how we, where we're going to fire it off and have it going and pulling the messages off the queue. So I maybe have 3 jobs that are running, and they're going to consume the queues until it's empty. Okay. So that's jobs for the most part. And then we also have scheduled jobs, right? So just like in Linux, we have the concept of cron jobs. We have the same thing in Kubernetes. I'm not going to insult people's ability to do analogies here. It's basically the same thing. The important part is the behavior and the differences between the job in regards to cleanup and times it runs. So when I do a lab on this, it was up to me to go back and clean up those job objects, which cleaned up the pod objects. As opposed to if I run a cron job in Kubernetes, I think I have the wrong syntax in here. I think the API version beta, let me verify. We might have a mismatch on some of our stuff. Let's see, just a second. Okay. Well, it looks like Kubernetes docs even has an issue here. Let's see what the older syntax ones. Let's see. Kubernetes cron job B1 beta 1. B1 beta 1. Okay, we'll have our answer here in a second. We make things work regardless. B1 beta 1. Let's try again. Oh, I'm changing it in the wrong thing. I'm sorry, folks. That's better. Okay, so I have one cron job in there. All right, it's scheduled to run. Last scheduled, none. Now, the way this works is we have 3 levels that are going to happen. I feel like I need video for this. We're going to have 3 levels that are going to happen. We're going to have, I put in the cron job, right? And I can do a wait on that. Well, at the same time, okay, cron job, pods, 3 letters. So I'm always only ever going to have one cron job in there. That's the YAML I put in the object I define. However, every time the cron job fires, it makes a new job. Every time the job tries to run the defined spec of the job, it creates a pod. If the job had a pod that failed, like we saw earlier, there would be n number of runs, n number of pods associated with that particular job and recorded as such. So every time the cron job fires, we get a new pod. And every time the pod runs a container, every time the pod runs, we get an instance. And if it would have failed, we get multiple of them, that retry object. So that's the distinction that I like to call out. The rest of the stuff is pretty straightforward and simple, but hopefully that makes sense on the cron job side of things. And this is actually that that one company I said that I had worked with before that used had a cluster dedicated just to running jobs and cron jobs. That's what they did. They actually had it was the kind of work they needed to do. Their architecture was one where they needed a lot of these cron job timed activity running, and it worked well for them. They sort of didn't have to do much, and they got a lot for free. So here you can see the first one was 1820, then the second instance was 1880, and then a 1940. Cool. All right, questions about cron jobs or jobs before I just briefly talk about the last workload type, which is of a daemon set.
Sure, I have one, Ryan. If I have, say, fairly complicated scripts that I want to convert to jobs, what's kind of the best way to do that in Kubernetes? Should I be creating new images? Should I try to make a new YAML format with all the bash script in there? What's your take on that?
Yeah, great question. So let's go look at, for example, the one we had here with the para. I think it was the para, right? So the first example wasn't bad, right? We had just a very short one-liner. Then this one starts to get a little bit bigger. And now if we're in the situation like that Andrew's asking, where the script is fairly complicated, should I embed it all in the YAML? That's one option. Not really the one I would suggest, but it is an option, right? The second thing is you could make a custom Docker image, right? So you could, instead of using image Debian stable slim, you could start with from that, and then you would copy the script into there and then just run it because it's already inside the image. I see my internet is not liking me. Let's see if we can make this work better. Give me a second here to tweak something. Okay. So that's another option. The negative there is you basically have custom images that you have to deal with. And then you also, if you need to update the script, you have to redo the entire, you have to make new images every time you update the script. A third option is you could inject the script in as an environment variable or as a mounted volume. So maybe you have a PV or PVC where you have your scripts there, and you could mount it into the Debian, into the Perl, or into whatever that common image is at a certain location, then execute it at that path. That would allow you to swap the container or the scripts independent of having to make custom images. You could also, we did it back in one of the earlier ones here. I think it was here. Let's take a look. In lab 9 of this workshop learning path series, we did dynamic application configuration. And there was an application in this lab series called the Go Web App. And one of its configurations was a JSON configuration file. And we actually embedded it inside of a config map and then injected the config map into the pod as an environment, as a file in the file system. So that would be the, well, I think we're up to option 4 now. The other option you could do, where you would make a config map in Kubernetes that held the contents of your script, and you injected that into the container and executed whatever file name you called it there.
Yeah, that's great. I like all those options. I think I enjoy the PV option the most, persistent volumes. That's what
Yeah,
I would personally prefer, just from familiarity perspective. And I think it'd be easy to manage on disk.
Yeah, totally. You know, some people, it's like personal preference, right? Some people are going to be more comfortable with the one versus the other. If you do the config map approach, you have to develop a process for getting them in and making sure they get picked up by the containers and so on and so forth. The scripts, it's not like it's a high volume transaction. It's not like there's usually not writing there. So you could probably get away with even something as simple as a read-only NFS PV that is mounted into the container that contains the scripts. And that would be fairly lightweight and simple, and probably a very common pattern that a lot of people are used to from historical designs. If you aren't familiar with the concepts I was talking about with regards to config maps and injection of them, lab 9 in part 3 or 4, I think it is. Let's see. It is part 4 has that. If you aren't familiar with the PVC side of things, then you can go to the same part 4, and lesson 8 and lab 8 have the PV and PVC side of things. Thanks. Okay, awesome. Thanks for that very good question that allowed us to explore some of the other features to see what may work. It depends upon, you know, your situation. The important part and the big thing we like to teach when we do this stuff here in Kubernetes is, you know, we give you the tools. You got your toolkit, you know, which, you know, when the hammer works better than the Phillips screwdriver versus the crescent wrench versus the socket. And then you pick which one you can use best, or maybe have you most of, right, in your toolbox to use for the problem you're trying to solve. Okay. Real quick, the last one on the daemon sets. These are, I want to run one per node. And the short and quick and easy answer here, these are great for agent style things that most sysadmins would do, like security scanners, log agents, and so on and so forth. You really don't see this object type, the daemon sets. You really use application side much. It's primarily used on the system administrator side of things. There are exceptions to the rule. However, generally speaking, it tends to be used on the administrator side more. So that's the set or suite of objects, jobs, cron jobs, daemon sets, etc., that we consider as additional workload types in Kubernetes other than your deployment and stateful set, which are common for most applications that run. Okay. So this is, we don't have a lab that I would normally demo for the security section here. The lab environment for this, we'd have to actually modify security to do it, which is not possible in a public no auth, no kind of situation environment. So we don't have one for it here, but we do have some stuff coming which will allow for that. But the security lesson is still there and I encourage you to look at it. I'm going to sit here and field questions if any come in, and I'm going to kick it back over to AJ to close up a little bit about this, and we can talk about some upcoming things and other potential webinars that we might try to do.
Thank you, Ryan. Thanks again for this 5-part series. Thanks to all of you guys for joining us today. Like Ryan had mentioned before, this has been recorded and will be up on YouTube. I did put links to some of the videos into the chat here, but what we're doing right now is putting all the videos into one playlist that we'll be sending out in the post email report. What I'm going to do right now is just plug in one of our upcoming events that's happening. Spring 1 is happening in person in San Francisco, December 6th through the 8th. I just put in a link so you could check it out as well. Registration is open. The discount ends, I think, next week. So feel free to check that out. Share that with any colleagues. If you're in the San Francisco Bay Area, it'd be great to see you guys there in person. And then Ryan also mentioned, this is the last in our 5-part core concepts KubeAcademy Office Hours series, but I believe there will be something coming in the next few months. So Ryan, we're hoping to bring you back in. And maybe Andrew, you'll be able to come in as well to help present to some of the folks here in attendance.
Yeah, that'd be great. We know that with on demand, it's nice, it's convenient, but it's sometimes nice to come on and watch it be done live, demos, and also ask questions. So if it goes well, we might do the same pattern for upcoming courses that are lab heavy.
Great. Yes. Yeah. Having your questions answered live by the man himself would be nice to have, a nice little touch. But again, we just like to thank all of you guys for joining us in this 5-part series. I do recognize some of the names here. You've been with us the entire way, so we're looking forward to having you come with us on the next journey for the next Office Hours series. So I would like to give a special thank you and welcome to Andrew for joining the team. And a special thank you for Ryan for this series, for leading the way, and for all the in-person events I know you've done in the past with KubeAcademy. We're looking forward to bringing those back in person in the future as well. So I don't know if there's any plug sessions that you have coming up or any events you have coming up, Ryan, but it's been a pleasure for myself to be on this journey with you.
Likewise, AJ. And yeah, no, I was just at VMware Explore earlier this month or this year out in San Francisco. And so we did talk about learning services and some of the stuff there, but you know how it goes. There's always stuff popping up. So
fantastic. Well, once again, thank you all. We'll be sending out a post-event email. Probably by tomorrow, you'll have the link to the playlist. And if you have any questions, you can reach out to Ryan directly. There's a question that just popped up here, right? I don't know if you saw that. Any preview of KubeCon North America Learning Day?
I can't say anything other than what's already on the advertised schedule right now. That stuff is planned and carefully coordinated well in advance, and the timing of it is out there is what it has to be. So I'm sorry, I can't preview anything. I would love to though. Another question about Tanzu training courses for Vmware admins. Yes. So we have, I'll get some links and put it in. So we're actually starting to add some stuff here, and we have some new things that will be launching. But if you go to, we have 2 learning subscriptions that are available. Here we have I'll put a link to the blog post in the chat that talks about our new learning subscriptions that we have that came out earlier this year. These a subset of this is complimentary and a subset of it is paid, and we're trying our best to do a good balance act on that. But that's the best thing I can offer at this time, and we're working actively. I can tell you 100% working actively to bring more content to KubeAcademy, the complimentary, and content to other places that are Tanzu specific as well, especially with all the new stuff that's coming out with vSphere and Tanzu in general. So.
Great. Thank you, Ryan. Thanks for the questions, Peter, and to Dennis. Once again, everyone who joined us today, we look forward to seeing you guys at our next set of events. Thank you, Ryan. Thank you, Andrew. Thanks all of you all. Have a great week.
Thanks, everyone. See you again.
Cheers, everybody. Have a good week.